Good morning, my dear students. Have you ever wondered that why the sun appears to be reddish in color at the time of sunrise or sunset? Or why the clear sky appears to be perfectly blue in color? Or why the traffic signals or the danger signals are usually painted red in color? We know about reflection of light. We have studied about it, that is the bouncing back of light is known as reflection. Then another phenomena is refraction, that also we have studied, that is bending back of light. Then another phenomena is the dispersion, in which the white light split into 7 constituent colors. But none of these phenomena help us to understand that why the color of the sky is blue or the sun appears red at this time of sunrise and sunset and different colors. So let us see what happens. Let us consider we have an opaque object in front of us and the source of light falls on it. What happens to it? The light will definitely not pass through it. Now if an incident light try to pass through an opaque object, if an opaque object is placed in the path of the incident light, will it be able to pass through it? No, definitely not. Light does not pass through the opaque object again. Now if the size of the particle is very small, as the size of the atom or the molecule, what happens to the incident light? It gets scattered. It gets scattered everywhere. The scattering means the phenomena of change in the direction of light on striking an obstacle like an atom or molecule. It can be a dust particle also or water droplet also. So if the size of the particle is very small, then the light is not able to pass through it, but it changes its direction, and this phenomena is known as scattering. In the year 1922, Indian physicist C.V. Raman discovered scattering phenomena for the first time. The laws of scattering was given by Lord Rayleigh, and according to it, the first law, intensity of scattered light is inversely proportional to the fourth power of wavelength. Means that the red color, which has the longest wavelength, and the violet color, which has the smallest of wavelength out of all the 7 colors, then in that condition red has the least tendency to scatter according to Rayleigh scattering. This is the reason why red is used in danger signals or in traffic signals, because red is least scattered by fog or by smoke, and because of this reason, because of its least tendency, it is used in the danger signals. Sun appear reddish at sunrise and sunset. This is again because the position of the sun at the time of sunrise or sunset is such that the rays has to travel a very long distance, but when the sun is overhead it travels a very less distance, or you can say least distance, at the time of noon. So the light of the longer wavelength they are able to reach so far, but the light of the shorter wavelength like blue, violet, indigo, they get scattered, and therefore they are not able to reach to the observer's eye. So the color which reaches to the observer eye is the red color, and therefore we see red or the orange color of the sun at the time of sunrise and sunset. So you can see it in this figure also. This is from your NCERT book. Now the clear sky blue in color, the reason for it is the atmospheric size of the particle. Now according to the second law of scattering, if size of particle is small, they scatter light of shorter wavelength. So if you can see, this is the incident light, and if this is a particle, the particle size is very small, then it scatters the shorter wavelength like violet, indigo or blue. Also, if the size of the particle is big, then they scatter light of longer wavelength. So longer wavelength, that is of red or orange color, is scattered. When the light enters in the atmosphere, the higher wavelength are least scattered and the shorter wavelength are more scattered. So after entering in the atmosphere, you can see it here. In the violet color scatters the most, and the blue is visible most probably with the blue eyes. Also, as the air will be much clear, the color of the sky will be blue, and if it is most of smoke particles, then it appears to be very light blue. So These are the effects that we have studied today. So keep studying.